Hi everybody, today we are going to talk about the definite integral, chapter 10.4. So far, we worked about the integrals like x to the power 2 dx, and you remember that we can integrate this function such that since we don't know what number is c exactly, we are going to call this kind of integrals as indefinite integral. Okay, we can find a numerical value for an integral if we are given the upper and lower limit. We are going to call this kind of integrals as definite integral. Let's have a look. For example, so we are going to have a function such that f of x dx. Now I'm going to specify the lower limit and the upper limit. A and B. It means that we are going to integrate the f prime of x dx from a to b. We are going to equate this function into the integral form, which is the primitive form f of x. We are going to have the lower and upper limit. To find the exact value, we are going to substitute for b and a. It means we will subtract f of a from f of b. Let's have some exercises. Exercises 10.4. Let's have the first one, 1a. Okay, let us evaluate. Six x dx from 0 to 1. Okay, we have the integral of 6x dx. We learn how to integrate this from 0 to 1. The upper limit is 1, the lower limit is 0. Let's go. First, we integrate the function 6x to the 2 over 2. You remember that plus c. In this, we are not going to write plus c. Let's write it in parentheses. So we have the upper limit, which is 1. The lower limit is 0. You see that we have a cancellation here. We get 3x squared. 3x squared from 0 to 1. It means you are going to substitute for 1 and 0, and let's get their difference. It means 3 times 1 squared minus 3 times 0 squared. 3 times 1 squared, which is 3. 3 times 0 squared, which is 0. So the final answer will be 3. Let's go on with the next sample, 1b. Similarly, we have integral from 2 to 5, x to the power 2 dx. As we said in the first, we will integrate x to the power 2, which is x cubed over 3. And then we will look for the upper and lower limit and their difference. So let's substitute for 3 and 2 in order. So here it is. 3 cubed over 3 minus 2 cubed over 3. 3 cubed, which is 27 over 3 minus 8 over 3. Since they have the same denominator, I could rewrite this as, which is that. Oops, I had something wrong here. I see that it is not 3. So let me delete here. Okay, we have upper limit 5 cubed. 5 cubed, which is 1 to 5. If we get the difference, we get 117. 117 divided by 3, I think it is 39. Yeah. Okay, once more. From 2 to 5 x squared dx, we integrate, which is x cubed over 3, from 2 to 5. So we substitute for 5 and 2, we get their difference, which is 117 over 3. The next example, 1c. Similarly, we have integral of the function from 4 to 9, which is given as root of x. Before starting, you should remember that root of x means x to the power 1 over 2. We can substitute instead of root of x as x to the power 1 over 2. If we integrate x to the power 1 over 2, it means x to the power 1 over 2 plus 1 over 1 over 2 plus 1. Okay, we are going to have the lower and upper limit as 4 and 9. Let's simplify our function. We get x to the power 3 over 2 over 3 over 2 from 4 to 9. Okay, let's substitute for 9 and 4 in order. We got 9 to the power 3 over 2 over 3 over 2 minus 4 to the power 3 over 2 over 3 over 2. If we simplify what we get here, 9 to the power 3 over 2, you should think that 9 is 3 to the power 2, which is cancelled by the denominator 2. We get 3 cubed, which is 27. So 3 over 2 in denominator, if we have division, we got 2 over 3 times, we got 27, minus similarly 2 over 3 times 4 to the power 4 means 2 to the power 2. We cancel by 2, we get 8. Similarly, we got, here it is, 2 over 3 is in common. I can have a common factor here, 27 minus 8. And our last step, 2 over 3 times, we got 19. So we get 38 over 3. 38 over 3, you can leave your answer such that, or you could say, which is 12 and 2 over 3. They are both acceptable. Let's go on with the exercise 2a. In 2a, we have a function which includes two terms. We will integrate from minus 1 to 2. We have a function 6x to the 2 x dx. Okay, let's integrate the function firstly and then let's substitute for upper and lower limits. 6x to the 2 we can integrate such that 6x cubed over 3 minus 2x to the power 2 over 2. This is our function. We will substitute for upper and lower limits. We have a cancellation here. We got 2x cubed minus, we have another cancellation, x to the power 2. Okay, if you substitute from minus 1 to 2, okay, for 2 we got 2 times 2 cubed minus 2 squared. We substitute for 2 and then we will take the difference. Don't forget, we substitute for minus 1. When we have minus 1, please be careful, write it in parentheses. We got here 3 minus 1 to the power 2. I couldn't write well here. Let me rewrite this. Okay, minus, we got substitution for minus 1. 2 times minus 1 cubed minus 1 squared. Okay, so in the next step we will have cancellation. We got here 2 cubed, which is 8 times 2, 16, minus 4, which is 12, minus, we got here minus 1 cubed, which is minus 1, times 2, minus 2, and we have here minus 1, we get minus 3. So basically we can get minus and minus, which is plus. Our final answer will be 15. Let me sum up the lesson. When we say indefinite integral, for example, x to the 2 dx, we say x cubed over 3 plus c. Since we don't know the exact value of c, we say it is an indefinite integral. When we are talking for definite integral, it is exactly the same. We will define the same function x to the 2 dx in the terms of lower and upper limits, like 2 and 5. We integrate it and we substitute for 2 and 5 and we take their difference. We can call this as definite integral. Okay, everybody, for today that's enough. I think you need to have more practice. Have a nice day. Goodbye.